Hello friends, in today's question, two coils P and Q are separated by some distance. When a current of 3 ampere flows through coil P, a magnetic flux of 10 raised to power minus 3 Weber passes through Q. No current is passed through Q. When no current passes through P and a current of 2 ampere passes through Q, the flux through P is. So this is, you can say, based on the mutual inductance as well as the flux linkages. So in this case we have two coils. So we can draw a rough approximate diagram. This is one coil and this is another coil. Let us call this coil as P and this coil as Q. So in the first part it says that the current is passed through coil P and the value of current is 3 ampere. So in the first case we have having a 3 ampere current through P, and under this condition the flux that passes through Q is 10 raised to power minus 3 Weber. So under this condition we are given that the flux through Q is our 10 raised to power minus 3. In the second case and in the first case it is said that there is no current through Q. Okay. So in this condition the current through Q is given as 0. So this is our first condition. In the second condition it says that a current of 2 ampere is passed through Q. A current of 2 ampere is passed, and under this condition we have to find out what will be the flux linked with the coil P. It means we have to find out phi P. And in second condition it is given that the current, let us call this as current Q, IQ, and this as IQ prime and this as IP prime, this is 0. So it basically means at any instant only one coil is having the current. In the first case only coil P is having current of 3 ampere. In the second case only coil Q is having a current of 2 ampere. So we are going to start with coil P and we are going to write an expression for the, you can say, magnetic flux through coil Q. You can say magnetic flux through coil Q when current flows through coil P. Flows through coil P, and that magnetic flux we can write it as phi Q, and that phi Q will be equal to M multiplied by current through a primary, that is IP. So this is our IP in the first part. Okay. And in this case IP is the current which is flowing through the coil P. So let me write it here as IP, and M is our mutual inductance between the coil. M is the mutual inductance between coils P and Q. So let us find out the value of M, because phi Q is given to us and we also know the value of IP. So therefore we can write that our M will be equal to phi Q divided by IP. It is given at 10 to the power minus 3 and current is given as 3 ampere, and this comes as 3 Henry 3. So this is the value of the mutual inductance. Now we come to the second case. Okay. So this was our case 1, when the current was only flowing through coil P. In the case 2nd, the current is now flowing through coil Q. Current is through coil Q, that is suppose IQ, and it is given as 2 amperes. And we assume that the flux linked between the two coils when the current is flowing through coil Q is our phi p. So we can say that the flux linked through coil P, let us suppose that is called as phi p, will be equal to mutual inductance M and current IQ. So we already know value of M, we just calculated. We also know the value of IQ, which is our 2 ampere. Therefore, we can say that our phi p will be equal to 10 to the power minus 3 divided by 3 and multiply by 2. And this will be coming approximately as 6.67 into 10 to the power minus 4 Webers. So this is the amount of the flux linked with coil P when the current is flowing through coil Q. And the options, we have 6.67 into 10 to the power minus 4. So option number B is the correct option. Option B is correct. So this completes the question. Thank you.